pünktlich on time.
Hi, it's so great to be back here. My name is Olga Willner, and I'm responsible for all projects IoT at the department at Deutsche Bahn that is in charge of the train stations. Some of you might already know me and our station clock from last year's Things conference. Who has already heard about our LoRaWAN station clock? Wow, that's quite a lot. I'm impressed. Well, so let's catch up on that today. And this year, my colleague, Oliver Brandmüller, he has joined me because he has developed a really cool tool, the PaxCounter, which is also part of our station clock now. And he will get into the technical details of our PaxCounter later on. So let's get started. So we are the part of Deutsche Bahn, DB Station and Service. We are the ones who build and run the train stations. And with over 5,000 train stations, we are one of the biggest, one of the largest facility managers in Germany. And for us, IoT technologies, they're becoming more and more important because we've got, quite a lot of few small train stations, like 1,000 to 2,000, that are even unmanned, meaning there's nobody on location. Like none of our staff is on location, but we want to be aware if our what's going on there on location, if our systems are working, and we are using IoT technology for that. And what we are using and why are we using LoRaWAN? Why this is the technology that we are really keen on using, I would just like to go quickly into that right now. First of all, what we are loving about us is that it's an open ecosystem, meaning we can build up our own efficient infrastructure. Second, what's also really good about it is that we can really build up the coverage where we need it. Again, because of the really small train stations that are in the middle of nowhere, there's not necessarily Wi-Fi. Sometimes there's not even edge. So it's really hard to get connectivity there. And that's where LoRaWAN is perfect. What is also great about LoRaWAN is that you need no SIM cards, no SIM card management, and we can really scale up our coverage based on demand. Yes, and now let's have a look into what our use cases are, what we are currently doing with LoRaWAN. And we have got two main purposes. The first one is having efficient operations, becoming even more professional in our operations. And the second one is providing a good customer experience, a great customer experience to our customers, the train traveler. And today I would like to start with, first of all, showing you what's been going on with our station clock for the last 12 months. Then I would like to show you what's been happening afterwards in the last 12 months, which other use cases we have started to working on. The first one, it's the train info screens. We have integrated LoRaWAN hardware in some of our train info screens. So if there's a power outage or if there's a network failure, there's going to be a last message sent with LoRa so that we are going to be aware of that. Another use case that we have been working on is a PaxCounter. This is a very special little device. It's this tiny blue box you can see here. And this one, it's doing Wi-Fi sniffing. And that's how it tells us how many persons, if it's 20, if it's 30, if it's 40, depending how much it is, are close to this tiny little blue box. And this data, there are so many use cases for it at the train stations. I'm going to go into this a bit more into detail later on. Our fourth use case is also very similar to the PaxCounter. It's the ESP32 that is also used as part of the PaxCounter, where we are currently working on together with the manufacturers of LED tubes to figure out how we can have this included in our LED tubes for lighting, because as you all know, where light is, there are people, so this is a great spot for people counting. And then another proof of concept I would like to show you today is another one I'm really working on right now, which is also very fascinating. It's winter service with LoRaWAN, and what we do there is we detect, based on sensors, if there's ice or snow, so we can manage our winter service operations in a more efficient way. So let's get started on our station clocks. Here we go again. The current status is that we have got around 60 station clocks of 3 different generations out at our train stations all across Germany. I think it's around 5 or 6 different train stations where those clocks are located. And currently, together with one of our clock manufacturers, we are working to have this clock ready for industrial-grade production next year. So that's what's been going on right now. Yes, and already last year we introduced this clock, which now it's going to be able to do 3 things. The very first use case that we identified was the remote monitoring of the clocks, meaning that there are sensors inside the clock that tell you if the lighting is working, if the clock hands are fine, if there's power, if something is broken or there might be humidity in the clock. So this was use case number 1 that we started with. Use case number 2 was time syncing clocks with LoRaWAN. You might think, why does Deutsche Bahn, why do they want to time sync clocks with LoRaWAN? But actually, the reason, it's quite simple. On the one hand, we have got train stations that are above the ground. And then you can use DCF77. This works quite well. But right now, if it's a train station that is below the ground, that is underground, we have those things called main clocks, and they've got cables, and it's getting really expensive having all those cables for time syncing, because DCF77 cannot go in, doesn't have such a good coverage inside or even below the ground. And LoRaWAN is extremely well suited for this use case. And the third thing we are doing now, which is brand new, I don't think I even talked about this last year yet. This is the Pecks Counter, the people counting device that my colleague Oliver will talk about later, and which is also going to be included in our clock. And yes, the fourth thing we are really have been waiting for is LoRaWAN firmware updates over the air. Because if you really want to roll out a large number of devices all across the country, particularly in remote places, it's not working if you have to drive or go by train to this place to do an update. So we were super excited yesterday when Johan and Jan, when they announced, now it's time for FOTA with LoRaWAN, because this is what we really need for our clocks. Yes, and basically, for the remote monitoring, what we are doing is we are sending the exact message what's wrong through LoRa to the gateway cloud, and then bam, there's a maintenance order in SAP, which looks like that. So we can see instantly, like, when did the error appear and what's been happening. So our technician, he knows straight away, oh, I have to go fix the clock, and he also knows which spare parts he has to take. Then, as said before, like DCF receivers, they do not work below the ground. If you've got a train station, like if you've heard about Stuttgart 21 in Germany, they are really looking forward to our clocks because meaning we have got LoRa clocks, they need no more cables. They can just do the time syncing with LoRaWAN. And yeah, then we have got the PaxCounter, where are many very exciting use cases behind it, because we believe the data we will acquire through the PaxCounter, it can really help us improve our operations. You know, because then we see when there's a peak, when we have to send people over for cleaning, for emptying out trash cans, or just to provide service, just to help our customer. And this, like, since we included in the clock, there are no rollout costs, and the ESP32 itself, it's quite inexpensive, which is like a really good and efficient way to get the relevant data at very low costs. And yeah, and like those clocks, the ones I talk to you about right now, the ones that are remote monitored, that do the time syncing with LoRaWAN, and that also contain the Pecks Counter. This is like our third generation of the pilot clocks. We installed a few of them in autumn in Hamburg, and yeah, that's where they now hang, and they tick and count people, which is really great. And now, since FOTA is ready, we are really ramping up the industry-grade product, really ramping up the engineering and the development together with our clock manufacturer. And now I'm going to be handing over to my colleague Oliver, who's going to go much more into the details what the Pecks Counter is actually doing, and also how you can use the Pecks Counter for your own projects and how you can contribute to the code.
Hello. Well, Olga is a very experienced speaker. I'm not, so sorry for that. I'm going to try to get a little bit into the history of the project. It all started out in the fall of 2017, actually with a small Raspberry Pi. There was a Python script available somewhere in the internet. How many people are around, so if you want to Google it. The Python had a LoRa hat, and we placed it somewhere in the station and made our first experiences with counting people by Wi-Fi frames. Actually, so that means we're counting Wi-Fi devices and not actually people, but however, there's a good correlation today. Soon after, we noticed, okay, you have a Raspberry Pi, you have a USB network, Wi-Fi card, several devices. It's quite big. It's not really handy. So the idea very soon came to put that on a smaller device, to put that on a microcontroller. To first gather some experience, I put that up actually a second time in a Linux box to get some experience for me how it actually works. But in the beginning of 2018, I did a first implementation of it in an ESP32 microcontroller, which is very well suited because it has a Wi-Fi module that is able to do the monitor mode. Then, well, I'm not really a programmer. However, I had some experience years ago. I got some help from other people, also from people around here. And we, in the spring of 2018, decided to put the project open source to GitHub. That's where you're going to find it. I'm going to have the URL later for you. And since then, the project developed very well. So we had a lot of people contributing. We had a lot of change in the code. So it was cleaned up. It got sensor support, everything. It was ported to several boards available in the market. Also, meanwhile, to get back to what Olga said, the Pecks counting is very interesting if you put it in places that you already have in our train stations, like the clocks, like in LED tubes. So what you currently see is a project we had where we actually had hardware designed to fit it into our LED tubes. Because if you put something up in an LED lighting you already have, or in a clock or somewhere, it's the total cost of ownership is very low, because in the process, in the maintenance process, you can build that smart technology into devices you already have. It's pretty expensive to put something up in the train station just new, so doing the maintenance cycles and putting it up there is a good idea. For the use case, the PaxCounter itself, you might know other solutions where you do tracking and locating people and whatever. The PaxCounter itself is a very simple device. It works on its own. It has a very small uplink channel, that's LoRaWAN. So all it does is it counts people that are at the moment round in a counting cycle of a few minutes, and then sends a number. That is not very advanced in one thing that has, for our purpose, it's just fine, because actually we just want to know how many people are there. You can have trends, and you see spikes or lows and can react on them for several use cases. So, for example, you can probably send security personnel if you see there are a lot of people when you don't expect them. Or you can plan a cleaning process somewhere when you see they had a lot of people there. Or you probably can delay the cleaning if you see there was nobody there. So this is use cases for just knowing the numbers, just knowing the trends. So for the background, we do Wi-Fi sniffing. Actually, every device you have in your pocket, like a mobile phone, tablet, or whatever, usually scans for Wi-Fi networks. When it's scanning for Wi-Fi networks, it also sends frames, and we can see those frames. We can see Wi-Fi frames when they are sent to devices when they are connected. Every device has a MAC address. We can see the unique devices. We have some problems like MAC address randomization in modern devices like iPhones or so, but if you have the short counting cycles, that is not a big problem when counting people. So that is, it's never about is it 20 or 23 people. You want to know is it 20 or is it 50 or is it 200 people around. For that, it's good enough. So we have we filter on vendor IDs. We only count mobile devices like smartphones and tablets. We are not counting any access points, any whatever devices are around that are doing Wi-Fi. We have short counting cycles that depends on the configuration that are probably something between 60 and 240 seconds. That depends a little bit on the use case we have. Problem by now is we only do 2.4 gigahertz as a ESP32 we chose doesn't do anything in 5 gigahertz. Most devices anyway are scanning in 2.4 gigahertz, so that is not a problem at the moment. Data privacy is one thing. What I said, we are not doing like tracking people somewhere. We are not even checking how long they are under the device. We are just producing numbers. That is good because we are completely GDPR compliant. Other solutions you might have seen that require big Wi-Fi installations can do much more advanced things, definitely. they are much more expensive, and you always have a problem with data privacy with these solutions nowadays. So what we are doing is we are not actually saving the MAC addresses, but we are hashing the MAC addresses. We are salting. The salt for the MAC addresses is changed for every cycle. So that means between 2 counting cycles, we cannot see, we cannot determine how long somebody is there. All that is open on the internet. Everybody can look at our code, so everybody can be sure what we are doing and that we are not tracking them to wherever they go. That means also no repersonalization of the data or so is possible. Now I come to a very important part. The project is still growing. It was by now done by many people, enthusiasts, programmers, well, people like me who have been programming 20 years ago and then probably not for a long time. So I tell you, be part of it. You see here our GitHub repository. If you're close enough, you may even scan the 3D barcode. So I invite everybody to be part of it. You can use the PaxCounter, and you can contribute. That would be very helpful. And now I give back to Olga.
Okay, well, as you can see, please join us. And yes, if Johan and Wienke are listening, it would be very great if at the next Things conference, we could even have a PaxCounter meetup, so we can see what everybody's been doing with the PaxCounter over next year. And yes, in our LoRaWAN station clock containing the PaxCounter, it's also gotten quite a good media echo. And our head of digitalization and technology, Professor Dr. Sabina Jeschke, she really loves it. She said to the German biweekly Der Spiegel, everything at Deutsche Bahn is supposed to be like the new station clock. Outside, everything remains the same, but everything inside is brand new. I would say that's the spirit. And that's also why we didn't just stick to the PaxCounter with innovating, but there are other projects going in the same direction with LoRaWAN happening at our company right now. For instance, right now we have got a proof of concept on winter service with LoRaWAN running right now. Like, the main issue is that when we have got snow and ice at our train stations, we have to be aware of it in a very short time, even if it's an unmanned train station. And currently, we are using the data of weather stations. Sometimes they are very close to the train station and on the same height, and so the weather situation is very accurate in the data. But for some train stations, this data does not work so well. And that's why right now we are testing a big range of different sensors to see how to get the real-time data from the station. So obviously, it's temperature, humidity sensors, rain sensors. Some of the sensors, they are invasive, meaning they are integrated in the ground at our platforms, and others are non-invasive. So for instance, they are fixed to the walls and measuring from there via optical methods the temperature on the ground by plus minus 0.2 degrees Celsius. So those sensors we are testing right now. And beyond that, we ordered something from a research project going on at the University of Wisconsin in the United States. It's a very novel type of sensor, and like what you do is you also integrate it into the ground. As you can see, it's gonna look very even with the surface. But they do not measure the temperature. But what they do is they detect ice based on changes in the electrical resistance. So this is a very interesting solution, which we are going to be trying out next. And yes, there have been many lab tests been made in the States, but now we are going to be the first one trying them out in the wild. So this is also going to be quite interesting, and we are really looking forward to the results with which sensor works best for our winter service. Beyond that, as I mentioned, we have got those so-called train info streams, SIM in German. That's what they look like. And they contain a LoRaWAN module, which is going to be used for the monitoring of network failures as well as power outages. Plus, we have got some of our colleagues here with us, and they are also doing a very exciting project at Deutsche Bahn. It's workspace monitoring by smart booking. And basically what they do is they measure if an office or desk is in use or not. And yes, they've got built up a solution for that. And if you want to talk to them, they are sitting right over there, Martin Kemper, Frank Specht. And yes, what else have we been doing is, because it's also about the infrastructure, that's why, together with Gemalto, we have integrated a small LoRaWAN gateway in one of our passenger information signs, which is being tried out with TTN right now. And beyond that, for us, it's also very important that we support smart city movements with LoRaWAN, and that's why our LoRa gateway that is on top of the train station, Berlin main station, that it's a community gateway, and every citizen of Berlin can use it to transfer his or her data. This gateway has been the very first outdoor gateway in Berlin, and Oliver, he rode his bicycle until Brandenburg an der Havel, which is quite far away, and he climbed on a tower there, and he actually had connectivity with LoRa 44 kilometers away, like all across the city, which made us really content. And this gateway, it's been awarded by the Senate Department for Economics, Energy and Public Enterprises in Berlin as a smart location in Berlin. It's gonna be included in an app, which is gonna be providing smart location tours around Berlin for tourists. And we are hoping the app is gonna be available soon, and LoRa fanboys and girls are gonna arrive at our train station to have a look at the gateway and transmit data of their amazing applications through our gateway. Plus, we are hosting a hardware lab, IoT and smart cities, because educational LoRaWAN is also very important for us. Like, we believe that citizens have to be empowered to implement their own IoT use cases. And that's why we as Deutsche Bahn are conducting a hardware lab, IoT and smart cities for women in the field of STEM in March. So everybody can find out how he or she can transmit his own data through TTN. And yes, I hope that we could all catch up what's been happening with LoRaWAN at Deutsche Bahn for the last 12 months. We still firmly believe that the LoRa journey is still just getting started, and there are many more use cases for all of us to still figure out, prototype, and then scale up. And yeah, that's what we hope to see you again for next year. And in the meantime, just follow us on Twitter if you want to catch up what's happening with LoRaWAN at Deutsche Bahn.
Thank you.
Thank you very much, Olga Willner and Oliver Brandmüller.